So in the last video, we talked about how centripetal force is caused by universal gravitation to give us the understanding of how a star can attract planets and other celestial bodies to travel around it, and how Kepler's laws are supported by Newton's laws and Newton's universal gravitation. One of the things, though, that a lot of people get confused is the idea of weightlessness. And we look at astronauts traveling around the Earth in the space station and in older videos of the space shuttle, and we see them floating and we think, oh, they're weightless. Weightless is a tricky term because a lot of people think weightless means having no weight. What weightless means is that the apparent weight is zero. If the person were to stop moving, and I'll talk about what I mean by stop moving in a second, we would find that their gravity is still very, very large, and you could see it over here on the right side of the screen. The average shuttle mission is only up a couple thousand kilometers, and so we are seeing people in our space shuttle having acceleration due to gravity of this value. Then why do we experience weightlessness? Well, it goes back to the elevator. We love the elevator problem. So in a very basic understanding, you could Google videos of people in flight simulators, specifically airplanes that are going to give people weightlessness. There's a famous one of Stephen Hawking flying in a low G airplane. And so what happens in those airplanes is they go way up in the air, as high as they can potentially get before their engines can't function because of the lack of oxygen. And then they start to plummet and they drop in a almost free-falling pattern, causing the persons to experience a extremely low gravitational field. They're falling out of the sky, basically, and they're falling with the airplane which is also falling out of the sky. And so if you're falling and the objects around you are falling, relative to those objects, you are weightless. You are able to move around because they are falling with you. And so when we talk about outer space, where our space shuttles are, where our uh, uh, satellites are, the space station, we are talking about an elevation, again, a couple thousand kilometers above Earth's surface. And so these objects are like the bucket of water I spun around earlier this year. They are traveling in space in a circular path, and they are ultimately falling inward as they are moving forward. And as they fall inward, they are propelled outward by their inertia, meaning that their path changes. And so they get this path of throw, catch, throw, catch, throw, catch, throw, catch, where they're constantly being pulled inward. And so to the person in the space shuttle, they are falling towards the Earth as fast as Earth is falling away from them, because as they are falling inward, the Earth's surface is also curving. So they're falling, Earth's surface is falling. They're falling, Earth's surface is falling. And that pattern means that they are in perpetual free fall around the Earth and have the appearance of weightlessness. So that is a little discussion on that topic and an understanding of how the centripetal forces are related to the free fall, or the apparent free fall that we believe is happening in space shuttles.